Good day and welcome to FTM, the channel dedicated to Ferra data models. Well, it is Friday again and time for an update to our weekly series Are We Winning?, where I look at the COVID numbers to see if we are making progress in this battle against the global pandemic. I've already updated the data, so let me go straight into FTM and open up my project. Let's start discussing the latest figures. Okay, so today I'm not going to look at the normal scaled figures. I'm just going to go straight into the relative figures, which is this. So here we look at a model, this red line, model I've constructed of the pandemic, and we really should be below this line in order to be winning the battle. We need to come down and be below and stay below this line. This is the number of reported new infections relative to population size. That's the model. Then this pink magenta-ish line is the US, and South Africa is the blue line. And you can see South Africa and the US in this race, and it's difficult to see who is winning this macabre race. But let me just zoom in a bit, and there you can see the US racing up but stabilizing, and they may even be turning a bit. They may even be on their way down at the moment, and the same for South Africa. South Africa running up rapidly, exceeding the new infections of the US relative to population size. But also lately, it seems as if it has stabilized. You can see the daily figures and the 7-day moving average, and coming down at the moment. The last couple of days, it seems to be coming down. Both of these figures are a very small fraction of the population, 0.02%. So let's hope this is a real turning point. But I'll look at that in some more detail in a moment. Okay, so that's it in terms of the new infections. Then I want to look at the fatalities or the deaths along with that. I do this every week. So, and what I'm looking at here is the number of deaths shifted back 14 days and multiplied by 100. And the argument goes like this. If one person dies today of COVID and the fatality rate is 1%, this means that 14 days ago, 100 people were infected. That's the idea of this. So this gives another measure of what the new infections were on this particular day. And it's just to sort of check the numbers and see that they're all moving in the same direction. And as you can see, the infections measured in this way is not yet aligning with what we see at the moment. So we need to see the same in both of these to at least have some kind of confirmation that we are seeing an end to this. And as I've said many times before, what I'm hoping for South Africa is something like this. This is what happened in New York. Here you can see the new infections running up, and when people thought it was the end of the world, it stabilized, peaked, and then started sliding down. So if we are at the moment making a turn like that, it is extremely good news. And you know, whenever there was a little blip like this, I was really hoping that might be the turn. We haven't seen it yet, but this has got some good substance behind it, and this may be the peak that we are waiting for. And then, let's say in about 4 months, from now, we should have everything under control, and life should pretty much be back to normal. Okay, so let's zoom in on this to see if that really is a peak or not. And what I'm going to do is I'm going to look at Diagnostic Report and just show you the code for that. So here you can see the code. It's called in FTM, it's called the Stat Report. Stat Report, and the name is the South Africa change, that's the D's for change in new infections. stat report of the South African figures, and I'm calculating the change in the figures. So let's see if that helps us. Now, if I look at that report, this is what happens. Because of the exponential trend in the figures, I cannot really use this, and I need to take logs as well. So let's do that. Let me show you the code. And so the next step is to change the to take the change in log of the South African figures. Now, to calculate the change in log, you just say dlin with capital L, dlin. The problem is that there's a couple of zeros. There's a couple of zeros in the data, and you can't take the log of a zero number. So I replace all those zero numbers, all those zeros with a missing value. That's what I'm doing here. So let's replace all the zeros with missing values, and then calculate the change in log. However, how do you calculate the change in log if the previous value is missing? You cannot take the change if in two consecutive numbers if one of them is missing. So what I'm doing here is, instead of using the normal change in log function, I'm using the change in log with this for previous added to it. And that will ignore these gaps. That will ignore the gaps that the missing observations generate, and it will just take two observations, no matter what the gap is between them, and calculate the change in log between them. So that's what I'm going to do next. And if I look at that report, this is what I see. And as you can see, this is what I should be looking at. This is making a lot more sense. There you see the change in the log of infections. There is the mean, 1 and 2 standard deviations above and below it. So from this I can see if the trend is changing or not. Sorry. Unfortunately here, there's a lot of noise at the outset. There's a lot of noise, so this is messing up the test. So I'm going to relook at this, but only from the 1st of April onwards. I'm going to chop off this part, throw it away, and just look at the latter part of the sample. Just to show you how I do that in code, let me go there. So I'm going to take exactly the same calculation as before, the change in log of the previous, after I've replaced zeros. There you see it. But this time I'm going to limit the calculation. So this calculation is limited to a starting date and an ending date. The starting date being the 1st of April and the ending date being some distant day in the future. So I'm just wrapping the latter part of this with a limit, and then I do a stat report on it. The output then looks like this. There's the output, and this looks encouraging. Look at that. Okay, this is the change in log of daily new infections, and as you can see, there's the mean, the average, and at the moment we are well below 1 standard deviation. We even reached 2 standard deviations a day or two ago. So if this continues, it seems that a peak is forming. It's still early days. I don't want to be overly optimistic, but there's reason to be optimistic. There's reason to hope that we are currently reaching our peak, and that in future we will see a reduction in these figures. Well, with that little bit of, let's say, hopeful news, I will say goodbye. Thank you. See you next time.